Hi, this is Yessenia Lopez.
And this is Billy Nguyen.
And this is our presentation for our midterm presentation for EGR 305 Advanced CATIA.
Yes, today we're going to be presenting the twin oscillating boxer steam engine. Yay! So the twin oscillating engine has 20 unique parts that were broken up into 3 different subassemblies, all of which can be seen on the next slide when the exploded view is shown. Yessenia modeled all the odd number parts while I measured all the even number parts. Conversely, Yessenia did all of the draft drawings and dimensioning while I took care of the assemblies and PowerPoint presentation. We both worked very well as a team. We met every Friday to make sure that all the deadlines and expectations for each week were met. And then we would meet after class to collaborate with each other to ensure that all of the parts, assembling, and drawings were completed to the highest standard. We kept a Google Drive running with all of the parts, and we would constantly communicate with each other through text message or Facebook Messenger to make sure that all the parts were updated so that we can work with the most current parts and data. So this is the exploded view for the twin boxer steam engine, and as you can see, all 20 parts and 3 unique subassemblies have been outlined further. This assembly was very challenging to put together just because of some of the weird quirks with the assembly of the final engine. For example, this piston right here was not parallel, or rather, it was not parallel to the straight line of the base plate. Instead, it was offset by an angle of, I believe it was 15 degrees, and that was so that it would fit on this hole with this pin when this piston was extended. So it was very challenging because the dimensioning sheet that was provided to us did not have any of these measurements. So through trial and error, I was able to figure out how to use the angle tool and the coincidence tool to get those parts to line up. It is worth mentioning too that the crank pins themselves and the crank plates could have been combined into a single assembly. However, in order for me to accurately model and assemble the crank pins, or rather the pistons and the piston shafts, it was a lot easier to have these parts as just individual pieces so that they can just connect to one another. Another quirk about this part were the holes in the base wood block part. In the dimension drawings, these have no dimensions because they are merely pilot holes for 2 screws of any dimension to fit inside of them. When modeling the base plate, I decided to go with a radius, or diameter rather, of M5. This in turn led me to select these 2 screws from the CATIA part catalog, and that's basically it. The same can be said also too for these nut pieces right here. Using the CATIA parts catalog, I imported these 2 M3 nuts. However, this time the diameter was defined in this piece right here, the piston stem. And aside from that, everything else was relatively straightforward. Some pieces that gave me some difficulty included the spring, because using GSD, there is no surface for me to constrain or to do an offset or contact constraint with, so I just used a manipulation tool to have it offset when it was sitting on the piston stem pin right here.
The piston cylinder subassembly was created using 3 simple parts: the piston cylinder, the cylinder block, and the cylinder block stud. Each part was constrained to each other using a combination of coincident and contact constraints. As mentioned previously, 2 sets of these subdivision assemblies were used in the final assembly. It is noted that the cylinder block had an extra mounting hole that was not used when attached to the base frame. This mounting hole could be seen here. This extra hole was featured in the parts sheet that was given to us by Professor Gribbins. This entered a little problem because we thought that we had to get an extra hole into the piston cylinder, but once it was all assembled, we realized that it was just a misconception of the sheet, and we actually did not need that extra hole on the piston cylinder, but the cylinder block did need it.
The piston stem assembly was a very unique subassembly to put together just because of the geometry provided by the piston stem itself. As I'm drawing now, both the big end and the piston were at very weird angles from each other, though their faces had to be parallel to one another. This was really challenging to do inside of the actual assembly because the piston itself, where the piston stem subassembly would sit, was at a very odd angle. And so while the plane of the piston assembly may be straight and perpendicular, sometimes the plane of the other piece would be offset. So it was very hard for me to get these two to line up in a straight manner. It's also worth mentioning that modeling the piston stem itself was very challenging given the radius and the geometry of the part itself. For instance, these curves were at a radius r, let me draw it here as well, which meant that if the radius or the radii were the same, the point where the line becomes tangent with the curve is at a 45-degree angle. The first time around I did this, I did not notice, and this made my drawing not work. So after figuring out that these two angles were indeed at 45-degree angles from each other, and that these angles were the same, that made the modeling process a lot easier. Aside from that, the piston and big end were really easy to model, and I had no issues with those.
The stiffening plate assembly was also very straightforward. This assembly also only consisted of 3 parts: stiffening plate 1, stiffening plate 2, and the crank bearing. The only thing worth mentioning was that both stiffening plates had a radius of 5 in the base, which attached to the rounded part of the crank bearing. Given how small the detail was in the sheet, it was very easy to overlook, as it did happen, and we had to go in back and give those spaces the radii of 5.
By using checklists with tasks and goals as seen in the image to the left, Billy and I were able to manage our times and contribution to the project. All tasks were divided evenly from assembly to report writing. Yessenia, myself, assumed position as team lead the first half of the project. I assigned and distributed the drafting workloads amongst Billy and I. I created all the unnumbered parts as referenced in the right side picture, and I created most of the drawings for most pieces along with the drawings for the assembly and the sub-assemblies. Billy created all the even parts, again referencing to the right side picture. He assumed team lead for the second part of the project, where he took charge of the assembly, PowerPoint, and logo. We were both very pleased with the overall project. Through effective communication, humor, and patience, the project was completed successfully without any real issues. We both assigned parts individually and met every Friday to discuss progress and goals of our coming deadlines. We collectively, throughout the project, asked questions, delegated work, and took over each other's work when needed. The end result of the project was a full assembled model of the twin oscillating boxer steam engine. Given the level of complexity regarding the items modeled, the difficulty in creating subassemblies and communication team members, the overall project was a success. While the drawings provided enough information for the model and constraints, some assumptions had to be made about parts. For instance, the hole diameters for the base frame were not defined. This meant, however, the model part needed not only to choose a hole size, but they also needed to import a corresponding screw of the same diameter through the CATIA's part catalog. Another part was difficult to model was the crank plate because of how the curves overlapped within the dimensions. In terms of communication and collaboration, there were no major issues. Both Billy and I met during class and on weekends to complete assigned deadlines and goals. Given both of our proficiency with CATIA, modeling the parts and individually communicating through texting was not a problem. We hope you have enjoyed our video for the twin oscillating boxer steam engine. Have a good day. Thank you.